In this section, 7.4, we're going to be adding and subtracting radical expressions. So our objectives of this section is to know how to add radical expressions, know how to subtract radical expressions, and be able to simplify radical expressions after adding or subtracting, or simplifying before adding and subtracting. So we want to understand radical expressions in adding and subtracting. The definition of a like radical is two radical terms are called like radicals if they have the same index and the same radicand. Like radicals can be added or subtracted by using the distributive property. In our example below, you will notice that 3 fourth root of 5 plus 4 fourth root of 5 has the same index and the same radicands for the two terms. I can take out the 3 and the 4 and add them together and have it then multiplied by the same index 4 and the same radicand fourth root of 5. So here are some of the examples that we have. Number 1 is the square root of 6 plus 2 times the square root of 6. And you notice in this particular case it's just going to be 3 square root of 6, right? Because I just add 1 plus 2, and that's just 3. For number 2, down here at the bottom, we have 7 square root of 5 plus 3 square root of 5 minus 2 square root of 2. We certainly can add these together, and we get 10 square root of 5 because we have the same radicand, but we don't have it in the last term, and so we have to leave it as 2 square root of 2. In number 3, we have three terms that have the same index and radicand, fourth root of 7, and so we are just going to be adding or subtracting the coefficients of those. In this case, I get 35 fourth root of 7 minus 2. And in the last one, we see that each of the terms have the same radical square root of 3, and so we just add or subtract the coefficients. This is a negative 10 plus 4, and I get a negative 6 square root of 3. So in these examples, we're going to simplify the radicand first before we do the addition or subtraction. So for example, in part A, we have 5 cube root of 8x plus 5 cube root of 125x. This is just 5 cube root of 2 cubed x plus 5 cube root of 5 cube x. And now you can see that we can take the 2 and the 5's out, so we get 10 cube root of x plus 25 cube root of x. And now we have the same index and radicand, so now we have 35 cube root of x is our final answer. So for part C, we're going to do basically the same idea. This is the square root of 150 x squared y, notice I'm going to write this as 25 times 6 x squared y, and then the second term I leave as 19, and I get 100 times 6 x squared y, and now I can bring out a 5 and an x, 5x over here, and I'm left with 6y here. And here I bring out a 10 and an x, and I get 190 x, and I'm left with 6y. Now the radicand and the index are the same, so I can add these two together. So I get 195x square root of 6y. So problem E, you say, oh gosh, how do I do that? So I'm going to take, under this radicand, I'm going to take a 49 out of both terms. So 49, and I'm left with x plus 1. And in the second term, I'm going to take out an x squared, and I get an x plus 1. Now I can simplify the 49x plus 1, and I get a 7x plus 1 here. And here I can take out an x, and I get a x plus 1 here. Now I have the same radicand and index, and so now I just am left with x plus 7 in parentheses times the square root of x plus 1. In the final problem, I'm going to rewrite this radical over here as the fourth root of y cubed over 3. I can do that. And then I have a minus, well, 5 fourth root of y cubed over 3. And now I have the same radical symbols, and I have the same denominator. So the numerators can add, and I'm left with a negative 4 fourth root of y cubed over 3. So there's my answer. So in this particular problem, I have done the problem for you. I started out with the problem, the perimeter is equal to 2 times the length plus 2w. I went ahead and substituted in for L and W. So square root of 22 times the square root of 20 plus 2x is equal to, of course, 24 square root of 5. I simplified this expression, and it simplifies to 4 square root of 5. And then I took out the 4 square root of 5 from both sides, and I'm left with 20 square root of 5 is equal to 2x. I divided both sides of the equation by 2, and I'm left with 10 square root of 5 is equal to x. In the second problem, again, I set up my perimeter statement. 10 square root of 2 is equal to 2x plus 2 square root of 8. I can simplify this expression to this expression, 4 square root of 2. And then I can subtract 4 square root of 2 from both sides of the equation, and when I do that, I end up with 6 square root of 2 is equal to 2x, and I divide by 2, and I end up with 3 square root of 2 is equal to x. So I would like you to continue to try to do some of the problems in the worksheets that are provided to you for the lecture notes, and then check the solutions. So in this section, we learned the following. When adding or subtracting radical expressions, the terms must have the same index in radicand in order to combine the terms' coefficients. The second thing we learned is that in simplifying radical expressions, numbers or variables under the radicand may be factored out based on the index of the radical. And we can do both operations. In other words, we would want to sometimes simplify the radical first that's under the radicand, and then if we had the same radicands in different terms along with the index, we could add the coefficients. Well, that concludes our section 7-4. Again, please review the notes and work some of the problems. And then the problem set of the day, I would like you to work and then turn them into me when I get back on Monday the 29th. Thank you.